Hi roboticist! In this video we are handing over from the last time and we are going to add the link 4 to our robots. So first of all, let's go to the URDF file and uncomment the link 4 and the joint that attach the link 4 to the edge of the link 3 that is named link 3 _ link 4. And then you need to uncomment the transmission tag for the joint named transmission link 3 link 4, and then we have finished our update in the URDF file, and we need to update our joint controllers configuration file. And so copy and paste, named the new joint joint 4 position controllers, keep the type as F4 controllers joint position controller as well, and of course change the joint name, so link 3 link 4, and last you just need to update the arguments of your controller manager nodes. So all the updates that we needed to do are done, so we can launch this launch file, and we're gonna see that the link 4 will appear at the edge of the link 3, just as we have modeled in the URDF file. So as you can see, the link 4 is correctly spawned in our cobots, and if we press play, nothing falls, meaning that the default values of the PID that we have put are okay. So refresh the topic, and we are going to looking for the joint 4 position controller, because we want to send a joint position command as we did for the last joints. So select the joint 4 position controller command, set the frequency at 100 Hz, and put 1.57, that is gonna be 90 degrees, and tip the windows and see what's happened. And you can see that is going, the link 4 is going to 90 degrees, which is okay. Then we can try to send a position controller to -90 degrees, and is responding well. So now, as we did for the others joint, we can send a sinus expression to the joint 4 with the amplitude of 90 degrees. So as you can see now, the joint 4 is oscillating between plus and minus 90 degrees. So what we can do now is to add to our plot the joint for position controller command topic and compare to the state process value to see if there's any misalignment or it's well overlapped. So we are adding now the command data topic. And now we can add the state process value topic of this joint. And see how this joint behaves to the input of the position controller. And you can see that there is a good overlapping, meaning that we don't have any important errors between the input that you are sending to the joint and the actual values of the joint itself. And what we can try now is to increase the velocity of the position command. And if we set 4, we always have this step disturb. But as you can see, there is the state process value that try to reach the command data, and in particular when we are approaching the 90 and minus 90 degrees, there is a good overlapping, so the error is 0, let's say. But when we are approaching the middle, let's say the 0 degrees, there is a mismatching between the data and the process value. So we are going to try to solve this problem by tuning the PID values. So let's try by increasing the integer value from 50 to 70 and see what's happened. It seems that the situation is improved. Let's try 80. Okay, it seems that the situation doesn't change so much, or better, just a little. There we have a little bit of improvement. And then let's check what happens if we increase the derivative value to 120, and it seems that nothing important relevant changed. And let's try with the proportional value and set it at 1000. And let's add again another values in derivatives, and let's put it 150. And it seems as of now, as a first guess, let's say that these free set of value, for the moment we can keep it as is. So what we can do now is to tune these three values of the joint 4 position controller even when we are moving the joint 3 position controller. So we are tuning two joints at the same time in order to understand and figure it out how they interact between each other due to the inertia values of the link itself that might affect the controller of the joints. So now we can restart all the simulation, and what we can do is to plot in one window the joint position controller, the joint 2 position controller, joint 3 and joint 4, with both the command topic and the state process value topic, in such a way that we have a good understanding of how all these joints are interacting, or better interfacing with each other. So let's start from the joint 2 position controller command data and process value. And then make the same for the joint 3 position controller and the joint 4. And after that we have add all these plots. We can start to move every joint and make them oscillate between plus and minus 90 degrees, and see and monitor the behavior of the state process value compared to the command data value for each joint. Okay, we are ready for activating all the joint command data. So we are gonna have a joint 4 position controller, joint 3 and joint 2. Let's start with the moving of the joint 2 position controller, and there is a good overlapping between the command data and the process value. So now let's activate the joint 3 position controller. And you can see from the simulation that the joint 3 is moving to plus 90 degrees, and then switch to minus 90 degrees, and then finally we have activated the joint 4 position controller, and we can see that in particular in the joint 4 position controller there is still a misalignment between the process value and the command data. So, but now if you think we have in just one plot all the behavior of these 3 joints, and we can see now by tuning the PID value of each joint if there is some kind of interference between the tuning of each joint. So something that I see in common between the joint 4 position controller and the joint 3 position controller is that when the angle, the position angle of each joint is approaching the zero angle, there is an offset or a delay, let's say. But when they are approaching the plus or minus 90 degrees, the errors tend to go to zero. So now let's tune the PID values for the joint 3 and joint 4. So let's start with the joint 3, and we still have the proportional, integer and the derivatives of a value of 750 and 100 respectively. Let's try to increase by 1000 the proportional value of joint 3 and see what's happened. Okay, it seems that the error is getting lower even when we are approaching the zero angle, and I'm following with the mouse the light blue and the purple zeta. So I think that adding 1000 with the P, the proportional value, is a good choice. So what you can do is to update right away the proportional value of the joint 3 position controller. And it seems to be stable over the time. So now what we can do is to tune the PID value of the joint 4 position controller, and before we have set the proportional value at 1000, but let's increase to 1700 like we did for the joint 3. And it seems that there is still an error when they are approaching the zero angle. Okay, I'm following with the mouse because it's the green and the brown, light brown curve. So let's increase the proportional value of the joint 4 by 300, so now it's gonna be 2000. And it seems that we have an improvement, but I'm not satisfied yet, so let's increase the integer value a little bit. And I'm still following the error over the time with my mouse. You can follow it as well. It's gonna be the green and the light brown curve, and I think that the error could be negligible. So we can update the proportional and integer value to the values that we have just tuned. Okay, that's all for today. I hope that you enjoyed this video, and if you like this video, don't forget to subscribe to the channel, gives a thumbs up, and turn on the notification bell in order to do not miss the next topic, where we are going to complete our robots. Again, thanks for your attention, and keep learning robotics with ROS.